Welcome to Sleepy Time Stories. Hey dear friends, let your mind quiet down, your breathing settle into a slow, easy rhythm, and let the weight of the day slip gently away. There's no need to hold on to anything right now. Just listen, and let the story carry you softly toward rest. Now, if you happen to be listening to this because you're hoping to drift off into a deep and peaceful sleep, then you've understood exactly why these stories exist. So perhaps you might consider subscribing. And while you're at it, leave a little note in the comments about where you are in the world and what time the clock shows where you lie. There's something truly special about imagining Tokyo waking up to its first pale rays of dawn, London pausing in the middle of its busy lunch hour, and Los Angeles finally turning out its lights at night. All of us, scattered across the map, quietly learning the same ancient tales. It's rather wondrous when you really stop to think about it. Now, let's return to Morocco. What made the discovery of Jebel Irhoud so completely revolutionary wasn't simply the immense age of those fossils. It was where they happened to be found. For decades upon decades, scientists had grown quite confident that they knew precisely the spot where humanity first drew breath. East Africa, the Great Rift Valley. That was the place where the oldest known remains of Homo sapiens had come to light. That was where our story supposedly began. They even gave a name that carried an almost biblical resonance, the Garden of Eden hypothesis. The idea was beautifully straightforward. Modern humans evolved in one very specific corner of East Africa, roughly 200,000 years ago. Then, about 60,000 years before the present, a small band of those early people walked out of Africa, and over many generations, eventually settled every corner of the planet. Every person born outside Africa, whether Aboriginal Australian, Indigenous American, Pacific Islander, or European, all of them were said to be descendants of that single, heroic migration, one point of origin, one great exodus, one unified story. This became known as the out-of-Africa theory, and by the 1980s and 90s, it was treated as established fact. It was elegant. It was supported by fossils and early genetic research. It made logical sense of the archaeological record. It explained why genetic diversity is richest in Africa and fades the farther you travel from that continent. Case closed. Story finished. Except it wasn't. Those skulls resting in Jean-Jacques Hublin's hands whispered a very different tale. They were discovered in Morocco, in North Africa, more than 3,000 miles away from the Rift Valley. And they displayed a curious mixture of traits, some startlingly modern, others more archaic. The face looked rather like ours, but the brain case was longer and lower, more primitive in shape. These weren't quite modern humans as we know ourselves today, yet neither were they something entirely other. They were us, but an earlier version of us in the middle of becoming. And they were scattered widely across Africa, not confined to one particular valley. Hublin himself said it plainly when the discovery was published in the journal Nature. He spoke of a hominin that was almost modern in its face, but still retained an elongated, more primitive skull. The key word he used was different, because if human beings were already spread across Africa 315,000 years ago, already showing regional variations, already adapting to diverse environments, from Mediterranean shores to parched deserts to steamy tropical forests, then the clean, simple story begins to fall apart. Perhaps there was never just one Garden of Eden. Perhaps there were many gardens. Maybe humanity didn't begin in a single location and radiate outward in an orderly wave. Maybe we emerged across an entire continent. Different populations evolving, mixing, separating, and coming together again over hundreds of thousands of years. Perhaps the tale of our origin is messier, stranger, and far more fascinating than anyone ever dreamed. And Jebel Irhoud was merely the beginning, the first crack in foundation that scientists had long believed unshakable. Because once you start pulling at that thread, once you begin questioning the basic narrative of human beginnings, everything starts to unravel in the most wonderful way. So what truly happened? Where did we actually come from? And why are researchers now saying that nearly everything we thought we knew about our origins needs to be completely rewritten? That is the story we are about to explore together. And let me give you fair warning. It will take us to places you never expected. To understand why scientists today find themselves rethinking human origins so thoroughly, you first need to appreciate just how completely the out-of-Africa theory dominated our thinking for so many years. This wasn't some minor hypothesis that researchers casually entertained. It was the very foundation of nearly everything we believed about our species' beginnings. But like most revolutionary ideas, it didn't start out that way. Go back to the late 1800s, and you'll find the scientific community in a state of complete confusion over human origins. Everyone agreed that humans had evolved. Charles Darwin had settled that question, but nobody could agree on where it happened. Some scholars looked at Neanderthal fossils discovered in Europe and declared that continent must be humanity's birthplace. Others pointed to finds in Asia, especially the so-called Java Man, and insisted we evolved there. Still others championed various locations around the world. It was a jumble of competing theories, national pride, and very limited evidence. Then, in 1871, Charles Darwin published The Descent of Man. Among many controversial ideas, he made a prediction that most of his colleagues found utterly ridiculous. Africa, he said, that is where humans evolved. His reasoning was elegant and simple. Africa was home to our closest living relatives, chimpanzees and gorillas. If we shared a common ancestor with these apes, then that ancestor most likely lived where they still live today. It made perfect sense. But Darwin had no direct evidence, only logic. And in science, logic without physical proof doesn't carry you very far. For the next 50 years, Darwin's prediction was largely ignored. The real action seemed to be unfolding in Asia and Europe, where fossil hunters were making spectacular discoveries. Java Man, Peking Man, Heidelberg Man. The early human family tree was gradually being filled in, and Africa was hardly part of the picture at all. Then, in 1924, everything shifted. Raymond Dart, an Australian anatomist working in South Africa, received a box of fossils from a limestone quarry near the town of Tong. Inside was a small skull, clearly some kind of ape, but with features that didn't quite fit. The teeth were wrong, too human-like. The brain was too large for an ape, yet too small for a human. And most tellingly, the hole where the spinal cord enters the skull, the foramen magnum, was positioned underneath rather than toward the back. This creature had walked upright. Dart named it Australopithecus africanus, meaning the southern ape from Africa. He published a paper claiming he had found a missing link between apes and humans. And the scientific establishment laughed at him. Not merely disagreed. Laughed. The skull belonged to a juvenile, they said. Just a baby ape. Nothing special. Real human evolution, they insisted, was happening in the civilized parts of the world, Europe and Asia, not in Africa. The racism underlying those objections was barely concealed. Many scientists simply could not accept that humanity, the crown of creation, had originated in what they considered a primitive continent. Dart was deeply disappointed but stubborn. He kept working, kept searching for more evidence, and slowly, grudgingly, other researchers began finding similar fossils in South Africa. By the 1940s, the scientific consensus was beginning to shift. Perhaps Dart had been onto something after all. Perhaps Darwin had been right. But it took the Leakey family to truly blow the doors open. Lewis and Mary Leakey were fossil hunting in East Africa's Rift Valley, a geological wonderland where millions of years of sediment lay exposed by tectonic activity. Other scientists had written off the region as unpromising. The Leakeys saw it very differently. Starting in the 1930s and continuing to the 1970s, they made discovery after discovery. Homo habilis, one of the earliest members of our genus, found at Oldoway Gorge in Tanzania. Homo erectus, clearly adapted for long-distance walking. And countless stone tools showing technological development across millions of years. What made the Leakeys' work truly revolutionary wasn't just the fossils themselves. It was the context. They could date their discoveries using layers of volcanic ash. They could reconstruct the environmental conditions in which our ancestors lived. They could trace technological progression over vast stretches of time. For the first time, human evolution wasn't merely a random collection of old bones. It was a story, a narrative of development that could be followed across millions of years. And that story was unfolding in Africa, exactly where Darwin had predicted. By the 1970s, The African origin of early hominids was settled science. But a new question arose. What about modern humans, Homo sapiens? Sure, our distant ancestors had evolved in Africa millions of years ago. But where did our own particular species originate? Some scientists argue for multi-regional evolution. The idea that modern humans emerged simultaneously in different parts of the world from different archaic populations. Others champion the replacement hypothesis, that modern humans evolved in one place and then spread outward, replacing every other human species they encountered. Then, in 1987, a team of geneticists at the University of California, Berkeley, published a study that seemed to settle the question once and for all. They had analyzed mitochondrial DNA from people all around the world. Mitochondrial DNA is special because it is inherited only from a mother, never from a father, which makes it perfect for tracing maternal lineages backward through time. When they constructed a family tree from all this mitochondrial DNA, something astonishing emerged. Every single lineage traced back to Africa. More specifically, they all converge on a single ancestral population that had lived in Africa roughly 200,000 years ago. The media immediately dubbed this common ancestor Mitochondrial Eve. The name was misleading. She wasn't the only woman alive at that time, nor was she the ancestor of every human from that era, only of every human alive today. But the name stuck, and it captured the public imagination like nothing before. Here was genetic proof, hard science, showing that all modern humans shared a recent common ancestor in Africa, combined with the fossil evidence the Leakeys and others had gathered. It created what seemed like an unshakable narrative. Out of Africa, that's where we came from. One origin point, probably in East Africa. One migration out of the continent, probably around 60,000 years ago. One story of human expansion that eventually populated the entire world. The theory was elegant, simple, and supported by multiple independent lines of evidence. Fossils, genetics, and archaeology all pointed to the same conclusion. By the 1990s, out of Africa wasn't merely accepted, it was taught as fact in every textbook, featured in every documentary, presented in every museum. The story had a compelling narrative arc. Humble beginnings in Africa, a dangerous journey into unknown lands, and ultimate triumph as our ancestors spread across the globe. It appealed to our love of adventure, our desire for clear origins, our need to understand where we came from. More than that, it provided certainty in a field that had been plagued by competing theories and incomplete evidence for decades. Scientists could finally agree on the basic outline of human origins. This consensus was comfortable. It was tidy. It left very little room for doubt or alternative interpretations. The few researchers who questioned the out-of-Africa narrative were generally dismissed as contrarians or as out of touch with the latest evidence. But there were questions the theory struggled to answer. Why did modern humans suddenly appear in the fossil record around 300,000 years ago with no clear ancestral forms? Why did early modern human fossils show up in such geographically distant locations at roughly the same time? How did a small population from East Africa manage to spread across an entire continent and beyond so rapidly? These weren't fatal flaws in the theory. They were merely loose ends, details that would presumably get sorted out as more evidence emerged. Nobody expected what actually happened. Nobody predicted that new discoveries would systematically dismantle nearly every major assumption of the out-of-Africa theory, because the evidence that emerged over the next 20 years didn't just fill in the gaps. It revealed that the entire story we've been telling ourselves was far more complicated, far stranger, and far more interesting than anyone had imagined. For decades, we thought we had the story all figured out. The origin of our species, where we came from, how we became human. It was elegant, simple, and profoundly satisfying. We came from one place, one small region of East Africa, one population that somehow became special, different from all the other hominins that had come before. This was a Garden of Eden model, and for a generation of scientists, it seemed like the only explanation that fit the evidence. The timeline went something like this. Around 200,000 years ago, give or take a few tens of thousands of years, something extraordinary happened in the grasslands and forests of East Africa. A new species emerged, not gradually, not through some slow evolutionary creep, but relatively quickly, Homo sapiens, anatomically modern humans, us. The fossils that anchored this entire narrative came from a place called Omo Kaibish in southern Ethiopia. In 1967, a team led by Richard Leakey discovered two partial skulls eroding out of sediments along the Omo River. They were remarkable specimens: high, rounded craniums, reduced brow ridges, chins, all the skeletal features that distinguish modern humans from our more archaic predecessors. Initial dating suggested they were around 130,000 years old. Later, more sophisticated techniques pushed that date back to roughly 195,000 years ago, perhaps even 233,000 years in some estimates. But regardless of the exact number, the implications seem clear. This was ground zero, the place where our species was born. Ethiopia, and more broadly East Africa, was a cradle of modern humanity. The story that emerged from these fossils was compelling. A small population, perhaps just a few thousand individuals, living somewhere in East Africa, underwent a series of genetic and anatomical changes that transformed them into something new. They developed the physical features we associate with modernity: gracile skeletons, large globular skulls housing bigger, more complex brains, and vocal anatomy capable of producing the full range of human speech sounds. But the physical changes were only the beginning. What really mattered, according to this theory, was what was happening inside those skulls. Because somewhere around 70 to 100,000 years ago, something switched on. Call it behavioral modernity, call it the Great Leap Forward, call it whatever you like. But the idea was that humans suddenly, almost overnight in evolutionary terms, became capable of things our ancestors had never done. We started creating art, carving figurines, painting on cave walls, making jewelry from shells and carved bone. We developed sophisticated tools, not merely the simple stone implements that hominins have been making for millions of years, but specialized tools for specific tasks: fishing hooks, sewing needles, throwing spears with carefully balanced weights and precise aerodynamic properties. Most importantly, we developed symbolic thinking, the ability to use one thing to represent another, to create abstract categories, to think about things that were not immediately present: the past, the future, the minds of other people, the nature of existence itself. This, they said, was what made us special. This was what separated us from every other species that had ever lived. And all of it supposedly originated in one place: East Africa, the Garden of Eden. The exit story was equally dramatic. For most of our species history, according to this model, we stayed in Africa. We were an African species, perfectly adapted to African environments, but unable or unwilling to expand beyond the continent. Then, around 60 to 70,000 years ago, something changed. A small group, perhaps just a few hundred individuals, crossed the narrow waters between Africa and Arabia. This wasn't random wandering. This was purposeful migration. Perhaps they were following the coastline, exploiting rich marine resources as they moved. The coastal migration hypothesis suggested these pioneering humans hugged the shorelines, moving from estuary to estuary, feeding on shellfish and stranded marine mammals, gradually working their way around the Indian Ocean rim. They moved fast. Within just 10 or 20,000 years, their descendants had reached Southeast Asia, Australia, and eventually the Americas. They carried with them all the innovations that had developed back in Africa: the art, the tools, the language, the symbolic thinking. And they used these advantages to outcompete every other human species they encountered: the Neanderthals in Europe and Western Asia, the Denisovans across the vastness of Central and Eastern Asia, the mysterious Homo floresiensis on the islands of Indonesia. All of them have been successful in their own right, surviving for hundreds of thousands of years in their respective territories. But when anatomically modern humans arrived, carrying the full package of behavioral modernity, they were simply overwhelmed. Within a few tens of thousands of years, all other human species were extinct. We were the only ones left, the victors in the great competition for planetary dominance. And we all traced our ancestry back to that one small population in East Africa. Those few thousand individuals who had crossed some invisible threshold and become truly human. The genetic evidence seemed to support this story perfectly. Studies of mitochondrial DNA, which passes only through the maternal line, suggested that every living human shared a common female ancestor who lived in Africa around 150 to 200,000 years ago. Scientists called her mitochondrial Eve, not because she was the only woman alive at the time, but because her mitochondrial lineage was the only one that survived to the present day. Y chromosome studies tracing the paternal line pointed to a similar conclusion. All modern humans descended from a population that had experienced a severe genetic bottleneck, somewhere between 50 and 100,000 years ago. The diversity in human DNA, compared to other great apes, was remarkably low. Chimpanzees living in a single forest in Central Africa showed more genetic variation than all 8 billion humans alive today. This suggested our entire species had passed through a demographic bottleneck, a period when our population crashed perhaps 10,000 individuals or even fewer. We had come terrifyingly close to extinction, but somehow that small population had survived, expanded, and eventually conquered the planet. The bottleneck explained everything. Why we are all so genetically similar despite living on every continent. Why there is more genetic variation within any human population than between different populations. Why the concept of biological race makes no scientific sense when applied to our species. We simply haven't been separated long enough for meaningful genetic divergence to occur. This had profound implications that went far beyond paleontology. The single origin model became a powerful argument for human unity. We are all Africans, the story went. Every human being alive today can trace their ancestry back to that small population in East Africa. Our superficial differences in skin color, hair texture, facial features are merely recent adaptations to different climates, meaningless variations on a fundamental genetic unity. It was a beautiful story, philosophically satisfying, scientifically elegant, morally compelling, and it dominated thinking about human origins for decades. Textbooks presented it as established fact. Museums built exhibits around it. Documentary filmmakers dramatized it with CGI reconstructions of brave, cognitively modern humans leaving Africa to populate an empty world. The narrative became so deeply entrenched that questioning it seemed almost heretical. But here's the thing about beautiful, elegant, satisfying scientific stories. Reality does not care how appealing they are, and the evidence that would eventually shatter this narrative was already accumulating, hiding in plain sight at archaeological sites across Africa and far beyond. The African Garden of Eden model had made specific, testable predictions. If modern humans emerged in East Africa around 200,000 years ago, then older fossils with modern features should not exist anywhere else. If behavioral modernity switched on around 70 to 100,000 years ago, then evidence of symbolic thinking, sophisticated tools, and artistic expression should not appear before that time. If humans first left Africa 60,000 years ago following coastal routes, then the earliest non-African sites should show up along those paths and should not predate that exit. For many years, the fossil and archaeological records seemed to cooperate. New discoveries fit neatly into the established framework. When they didn't, researchers found creative ways to explain away the anomalies. That early site, probably misdated. Those advanced tools, probably made by some archaic species we don't yet know about. Those modern-looking fossils from outside the supposed cradle region, probably not actually modern, just convergently evolved similar features. But eventually, there were too many anomalies, too many sites that did not fit the expected pattern, too many fossils found in the wrong places at the wrong times, too much evidence that the simple, elegant story was missing something crucial, something that would force us to completely rethink what we thought we knew about where we come from and what it means to be human. The African Garden of Eden wasn't wrong exactly. Humans did originate in Africa. Our deepest genetic roots are African. But the reality turned out to be far more complex, far more interesting, and far less tidy than the single origin model had suggested. Africa was not one garden. It was many gardens, multiple populations, multiple regions, all contributing to the emergence of modern humanity. And the story of how scientists came to understand this begins with a site that nobody paid much attention to at first, a cave in Morocco that would eventually rewrite everything we thought we knew. For decades, The Out of Africa story was told with great confidence. Humans evolved in East Africa, somewhere around Ethiopia or Kenya, roughly 200,000 years ago. Then, around 60,000 years ago, a small group walked out and colonized the world. Simple, clean, elegant, except it wasn't true. Or, at least it wasn't the whole truth. The cracks started appearing almost immediately, but nobody wanted to see them. Not because scientists were dishonest, but because once a theory becomes dominant, once it gets taught in every textbook and referenced in every paper, questioning it becomes professionally risky. You risk looking like a contrarian, a troublemaker, someone who doesn't understand consensus. So the anomalies got explained away. The contradictory evidence got filed under interesting but not significant. And the Out of Africa narrative rolled forward like a freight train, gathering momentum with every passing year. But the fossils did not care about consensus. They simply sat there in the ground, waiting to complicate everything. Take the Florisbad skull, found in South Africa in 1932, decades before the Out of Africa theory even existed. That skull showed a strange mixture of archaic and modern features. Too modern for Homo erectus, yet too archaic for fully modern humans. It should have been a warning sign that human evolution in Africa was not a simple, linear progression, but instead it got sidelined, treated as a weird outlier, a developmental dead, and that didn't lead anywhere important. Then there were the North African sites, Morocco, Algeria, Libya, places where archaeologists kept finding stone tools and fossil fragments that seemed too sophisticated, too modern for their supposed dates. Tools that matched the kinds of technology supposedly invented in East Africa. Except they were showing up thousands of miles away, sometimes at dates that made no sense according to the standard model. The usual explanation was migration. Modern humans evolved in East Africa, then spread north, bringing their technology with them. Problem solved. Except the dates kept getting pushed further and further back. Sites in Morocco showing sophisticated Middle Stone Age technology at 300,000 years ago. That was 100,000 years earlier than modern humans were supposed to exist. Something was not adding up. But here's the crucial thing about Africa. It is not a single place. It is an entire continent, the second largest landmass on Earth, spanning from the Mediterranean Sea to the Cape of Good Hope, from the Atlantic Ocean to the Indian Ocean. It contains tropical rainforests, vast savannas, harsh deserts, mountain highlands, coastal zones, and everything in between. Treating Africa as a single, homogeneous evolutionary laboratory was rather like treating Europe and Asia as one identical environment. It made no sense at all. Yet, that is exactly what the Out of Africa theory did. It imagined human evolution happening in one special spot, probably somewhere in the East African Rift Valley, with all the important innovations occurring there before spreading outward. But evolution does not work that way. Different environments create different selection pressures. Populations adapt to local conditions. Genes flow between groups living in adjacent territories, creating gradients of genetic variation rather than sharp boundaries. If humans were evolving across the entire African continent for hundreds of thousands of years, you would expect to see regional variations, different populations developing different traits, then occasionally mixing and sharing genes and technologies. You would expect a messy, complicated evolutionary tree with multiple branches, not a single straight line from primitive to modern. And that, as it turns out, is exactly what the evidence was starting to show, if only anyone had bothered to look closely. The problem was partly about where scientists chose to dig. East Africa, particularly the Rift Valley, has exceptional fossil preservation. Volcanic eruptions create layers of ash that can be precisely dated. The geology is ideal for finding and dating ancient bones. So that is where the funding went. That is where the expeditions focused. And unsurprisingly, that is where most of the famous fossils came from. But absence of evidence is not evidence of absence. Just because we had not yet found early human fossils in other parts of Africa did not mean they were not there. It might simply mean we had not looked hard enough, or that preservation conditions in those regions were not as favorable. West Africa, for instance, has tropical conditions that destroy bones very quickly. The Sahara Desert has spent millennia burying or eroding potential fossil sites. North Africa had been largely ignored by paleoanthropologists, who assumed anything truly important would be found further south. This created a massive preservation bias. Our picture of human evolution was being shaped not by where humans actually lived, but by where their bones happened to survive and where scientists happened to look. Then the geneticists started finding something even more puzzling. Ghost populations, that's what they called them. Signals in the DNA of living Africans suggesting that their ancestors had interbred with ancient populations that have left no fossil record whatsoever. The genetic signatures were clear. Modern West Africans carry DNA from an archaic human population that split from our lineage hundreds of thousands of years ago. Modern East Africans show a mixture from a different ancient group. Southern Africans have genetic contributions from yet another mysterious population. These ghost populations were not Neanderthals or Denisovans. They were African. They had been living on the continent alongside our ancestors for tens or even hundreds of thousands of years. And then they had interbred with them, leaving genetic traces that persist to this day. But where were their fossils? Where was the archaeological evidence of these other human species? The answer was probably quite simple. We had not found them yet, or we had found them and dismissed them as odd individuals rather than recognizing them as evidence of separate populations. The Iwo Eliru skull from Nigeria is a perfect example. Found in 1965 and dated to just 13,000 years ago, it showed remarkably archaic features. Heavy brow ridges, thick cranial bone, primitive morphology. It looked like something that should have been 100,000 years older. For decades, it was treated as an anomaly, perhaps a diseased individual or a genetic throwback. But what if it was actually evidence of a ghost population? What if archaic humans had survived in West Africa until extremely recent times, living alongside modern humans and occasionally interbreeding with them? The genetic evidence pointed in exactly that direction. But accepting it meant accepting that human evolution in Africa had been far messier and more complex than anyone had wanted to believe. There was also the uncomfortable fact that some researchers had been saying this all along. The multi-regional evolution hypothesis, proposed back in the 1980s, had suggested that modern humans evolved simultaneously across multiple regions, with gene flow between populations maintaining our species unity, while allowing for regional variations. That hypothesis was viciously attacked by out-of-Africa proponents. It was associated with outdated ideas about racial differences. It seemed to contradict the genetic evidence for an African origin. And frankly, it was complicated. The out-of-Africa model was simpler, cleaner, easier to teach and easier to understand. So multi-regional evolution got sidelined, dismissed as fringe thinking. Its supporters found it harder to get funding, harder to publish in prestigious journals. The scientific community had made its choice, and anyone who disagreed was swimming against a very strong current. But here is what nobody wanted to admit. The multi-regional people had been right about some things. They had recognized that human evolution could not be reduced to a simple out-of-Africa migration. They had understood that populations in different regions could develop distinct traits while still maintaining enough genetic contact to remain a single species. They had simply been wrong about the geography. They thought the multiple regions were different continents. It turns out the multiple regions were all within Africa. The scientific culture around human origins research had become tribal. You were either team out of Africa, or you were simply wrong. Questioning consensus, even with good evidence, meant risking your professional reputation. Young researchers learned quickly not to push too hard against the dominant theory. Funding agencies preferred safe projects that would confirm what everyone already believed. This created a kind of intellectual inertia. The theory became self-reinforcing. Evidence that supported it was published prominently. Evidence that contradicted it was buried in obscure journals or explained away with ad hoc hypotheses. And anyone who pointed out the contradictions was labeled a troublemaker. But science has a wonderful way of correcting itself eventually. The fossils keep coming out of the ground. The genetic evidence keeps accumulating, and sooner or later, the weight of contradictory evidence becomes too heavy to ignore. By the early 2000s, that moment was approaching. The cracks in the foundation were becoming chasms. The anomalies were piling up faster than they could be explained away. And a few brave researchers were starting to say publicly what many had been thinking privately. The out-of-Africa theory, as originally conceived, was at best incomplete and at worst fundamentally wrong. Human evolution in Africa had been far more complex than anyone had imagined. Multiple populations, multiple regions, multiple evolutionary experiments, all happening simultaneously across the continent. But it would take a spectacular discovery to finally break the consensus, a find so significant that it simply could not be dismissed or explained away. A fossil that would force the entire field to reconsider everything they thought they knew. And that discovery was about to emerge from a cave in Morocco, of all places, far from the supposed cradle of humanity in East Africa, in a location where modern humans were not supposed to have existed at the dates the fossils would ultimately reveal. Everything was about to change. Now we arrive at the heart of the matter, because everything we had just discussed, all those careful reconstructions of human evolution, all those theories about African origins, were built on a foundation that was about to crack wide open. The year was 1961, not in some prestigious research facility, not during a planned archaeological expedition, but in a barite mine in Morocco. Workers were digging into a hillside called Jebel Irhoud, simply looking to extract minerals for industrial use, when they hit something that was not supposed to be there. A human skull embedded in very old rock. The mining company did what they were supposed to do. They called in scientists. French and Moroccan researchers arrived and began carefully excavating the site. What they found was remarkable. Not just one skull, but multiple individuals, adults and children, along with many stone tools. But here was the problem. The skulls were strange. They had faces that looked reasonably modern, high cheekbones, relatively flat profiles. Yet their brain cases were long and low, more archaic in shape, like something intermediate between earlier human species and modern humans. So, the scientists did what made sense at the time. They classified the fossils as Neanderthals, or perhaps some kind of African Neanderthal cousin. The dating techniques available in the 1960s suggested the remains were perhaps 40,000 years old. Interesting, certainly, but not revolutionary. Just another data point showing that human evolution was messy and complex. And then the fossils essentially disappeared from the main narrative of human origins. They sat in museums. They were mentioned occasionally in academic papers. But they did not fit neatly into the emerging out of Africa story. So they were sidelined, treated as curiosities rather than crucial evidence. Decades passed. The out of Africa theory became dominant. The search for human origins focused on East Africa, Ethiopia, Kenya, Tanzania. That everyone believed was where the important fossils would be found. That was where humanity began. But some researchers could not stop thinking about those strange Moroccan skulls. Enter Jean-Jacques Hublin, a paleoanthropologist who had spent decades studying human evolution. Hublin looked at those Jebel Irhoud fossils and saw something everyone else had missed. Those faces, they were not Neanderthal. They were too modern, too much like us. What if he thought they are not 40,000 years old? What if the original dating was simply wrong? So in the early 2000s, Hublin assembled a team and went back to Jebel Irhoud, not to the old mining site, which had been destroyed, but to nearby areas that might still contain undisturbed fossils. They spent years carefully excavating, sifting through sediment, looking for anything that might have been missed. And they found it. More skull fragments, more bones, more tools. But more importantly, they found material that could be dated using modern scientific techniques. The dating methods available in the 1960s had been crude, mostly guesswork based on geological layers and associated animal fossils. But by the 2010s, scientists had something far better: thermoluminescence dating. This technique measures when certain minerals were last exposed to heat or sunlight, perfect for stone tools that had been heated in ancient fires. Hublin's team collected flint tools from the archaeological layers. They sent them to specialized laboratories. And then they waited. When the results came back in 2017, nobody was prepared for what they showed. The Jebel Irhoud fossils were not 40,000 years old. They were 300,000 years old. Perhaps even a bit older. 300,000 years. Let that sink in for a moment. The oldest previously accepted Homo sapiens fossil from Ethiopia had been dated to about 195,000 years ago. These Moroccan fossils push the origin of our species back by more than 100,000 years. But that is not all. Jebel Irhoud is not in East Africa. It is in Northwest Africa, Morocco, about as far from the supposed cradle of humanity as you can possibly get while still staying on the same continent. The scientific paper announcing the discovery landed like a thunderclap in 2017. It was published in Nature, one of the most prestigious scientific journals in the world. The title was careful and academic, but the implications were truly revolutionary. Picture what these ancient people looked like. They had faces that would blend in reasonably well in a modern crowd. If you dressed one of them in contemporary clothes and had them walk down a city street, you would notice something seemed a little off, but you might not immediately realize you were looking at a different kind of human. The face shape was right. The proportions were mostly modern, but turn them around. The back of the skull told a very different story. Long, low, stretched out. The brain case had not yet become fully globular. It still retained a more archaic shape. Brain size was similar to ours, but the brain itself was organized somewhat differently, less expanded in the frontal regions associated with complex planning and abstract thought. So what were they? Hublin's team called them early Homo sapiens, the oldest members of our species yet discovered. But they were not quite us. They were us in progress, us in the process of becoming. And the tools. Oh, the tools. This is where things get truly fascinating. The stone tools found at Jebel Irhoud were made using something called the levallois technique. This is sophisticated work. You do not simply bash rocks together and hope for the best. You carefully prepare a stone core, shaping it so that when you strike it in just the right place, it produces a thin, sharp flake with a predetermined shape. This requires planning, abstract visualization, the ability to see the finished tool hidden inside the raw stone before you even begin working. It requires teaching and learning because nobody figures this out by accident. The levallois technique was supposed to be an East African innovation associated with the later stages of human evolution. But here it was in Morocco, 300,000 years ago, being used by people whose skulls were only partially modern. The immediate reaction from the scientific community was complicated. Excitement mixed with skepticism, mixed with a fair amount of territorial academic anxiety. Because if Hublin was right, if these really were early Homo sapiens, then nearly everything needed to be reconsidered. Some researchers immediately embraced the findings. Finally, they said, finally, someone is paying attention to the rest of Africa. The East African bias in human origins research had always bothered them. This was vindication. Others pushed back. Maybe these were not Homo sapiens at all. Maybe they were some other species that just happened to look similar, or maybe they were Homo sapiens, but they were an evolutionary dead end, a failed experiment that went extinct while the real action was happening back in East Africa. But the evidence kept piling up. Other sites in Morocco yielded similar fossils, similar tools, all from roughly the same time period. This was not a fluke. This was a population, a successful, widespread population of early humans living across Northwest Africa hundreds of thousands of years ago. And they were not isolated. The stone tool traditions at Jebel Irhoud show connections to sites thousands of miles away. Similar techniques appearing in East Africa, West Africa, even the Middle East. These people were connected. They were part of networks that stretched right across the continent. This is when the Pan-African origin hypothesis really started taking shape. Not humans evolving in one small area and then spreading outward, but humans evolving across all of Africa simultaneously. Multiple populations in different regions, connected by migration and gene flow, all contributing to what would eventually become Homo sapiens. Jebel Irhoud showed us that 300,000 years ago, people with nearly modern faces and sophisticated tool technologies were living in Northwest Africa. Other sites were showing similar dates for fossils in East Africa, South Africa, West Africa. Different populations, slightly different skull shapes, but all trending in the same general direction, all becoming more modern over time. It was as if evolution was conducting the same experiment in multiple locations at once. Each population adapting to local conditions while remaining just connected enough to share innovations and genes. Some populations developing certain modern traits faster than others, but all of them moving toward the same endpoint, The Moroccan Revolution, as some researchers started calling it, was not merely about one site or one set of fossils. It was about recognizing that Africa is not a small place. It is enormous, diverse, full of different environments and ecological opportunities. Why would humans evolve in just one tiny corner of such a vast continent? Why would evolution not take advantage of all that space, all those different selection pressures? The simple story, the Garden of Eden story, was falling apart, not because it was entirely wrong, but because it was incomplete, dangerously simplified. A narrative that fit our desire for tidy origins, but did not match the messy reality of how evolution actually works. Hublin and his team had cracked open a door, and behind that door was a much bigger, much more complex story. A story that was still being written in the rocks and sediments of Africa. A story that would force us to completely reimagine what we thought we knew about where we came from. But Jebel Irhoud was only the beginning. Because once researchers started looking beyond East Africa, truly looking, they started finding evidence everywhere. Evidence that the story of human origins was far bigger than anyone had ever imagined. For decades, we had imagined a single garden. One perfect place in Africa where the first modern humans evolved. One population becoming smarter, more sophisticated, more human, then spreading out to conquer the world. It was a beautiful story. Simple, elegant, and completely wrong. Africa is not one garden. It is an entire continent. 11.7 million square miles of deserts, rainforests, savannas, mountains, and coastlines. Thousands of distinct ecosystems separated by massive geographical barriers. Rivers wider than most countries. Deserts that stretch for 1,000 miles. Mountain ranges that pierce the clouds. Rainforests so dense that populations living 50 miles apart might as well be living on different planets. And we had somehow thought that modern humans evolved in just one small spot within this vastness. That is not how evolution works. That is not how anything works. The evidence had been staring us in the face for decades. We just had not wanted to see it. Or perhaps we could not see it because we had been looking for the wrong thing. We were searching for the cradle of humanity, singular, when we should have been searching for cradles, plural, a network of populations scattered right across the continent, evolving together but also separately, connected by threads of gene flow, yet isolated enough to develop their own unique characteristics. This is what scientists now call African multiregionalism. It is a bit of a mouthful, but the concept itself is actually quite straightforward. Instead of one ancestral population giving rise to all modern humans, we are looking at multiple distinct groups spread across Africa, exchanging genes whenever their ranges overlap, but spending most of their time evolving independently in response to local conditions. Think about what Africa looked like between 300,000 and 100,000 years ago, the period when modern humans were supposedly emerging. The continent was experiencing wild climate fluctuations. About every 20,000 years or so, the entire geography would transform. During wet periods, the Sahara was not a desert at all. It was green. Rivers flowed through what is now endless sand. Lakes appeared where today there is nothing but rock and dust. Animals migrated north from sub-Saharan Africa, and human populations followed them. Then the climate would shift again. Within just a few thousand years, those green corridors would vanish. Populations that had been connected would suddenly find themselves separated by expanding deserts. The Sahara would become an impenetrable barrier, cutting off North Africa from the populations further south. And those separated groups would begin evolving in different directions. This pattern repeated over and over again. Green Sahara, genetic exchange, population mixing. Then drought separation, independent evolution. Then green Sahara again, reconnection, more mixing. For hundreds of thousands of years, African human populations played this elaborate, ongoing game of connection and isolation, coming together, drifting apart, coming together again. And every time they reconnected, they brought new genes, new technologies, new ideas with them. The groups that had spent millennia adapting to the forests of Central Africa would meet groups that had evolved in the grasslands of East Africa. Populations from the Mediterranean coast would encounter people from the Southern Cape. They would exchange genes, share knowledge, and create children who carried adaptations from multiple different environments. The archaeological evidence of this pattern is stunning once you know what to look for. Take Jebel Irhoud in Morocco, where those 300,000-year-old fossils turned the field upside down. The people buried there had a strange mixture of features, modern-looking faces, but archaic skull shapes. This was not what you would expect from a single population evolving steadily toward modernity. This was what you expect from a population that was part of a larger network, exchanging genes with other groups that had somewhat different evolutionary trajectories. Then consider Florisbad in South Africa, nearly 2,000 miles to the south. Fossils found their date to around 260,000 years ago, and they show a different mix of features. More archaic in some ways, more modern in others. Not because the people of Florisbad were at some different stage of evolution than the people at Jebel Irhoud, but because they belonged to different regional populations within the same continental network. Move east to Ethiopia and you find the Herto skulls, dating to about 160,000 years ago. These look distinctly more modern than either Jebel Irhoud or Florisbad. Larger brain cases, more gracile bone structure, features that would fit quite comfortably on any modern human. But were they the first true modern humans, or simply one population within the larger network that happened to have evolved more modern-looking features earlier than other groups? Tanzania gives us even more complexity. Sites like Litoli show human occupation stretching back millions of years. But during the critical period between 300,000 and 100,000 years ago, we see something intriguing. Stone tool technologies appear suddenly, persist for a while, then disappear, only to reappear thousands of years later. This is the signature of populations moving in and out of the region, waves of migration bringing new technologies, followed by local populations either adopting them or disappearing, replaced by new groups with different cultural traditions. The picture that emerges is breathtakingly complex. Africa was not one population evolving in one place. It was dozens, perhaps hundreds, of distinct populations scattered across different environments, connected by corridors that open and close with the shifting climate cycles. Rivers were critical to this network. The Nile, flowing north through the entire continent, connected Mediterranean Africa to the tropical interior. During wet periods, when the river ran strong and its tributaries expanded, populations could move along these watery highways, carrying genes and technologies thousands of miles. The Congo River system did the same thing in Central Africa, creating connections between the Atlantic coast and the interior forests. The Zambezi in the south, the Niger in the west. These were not merely sources of fresh water. They were communication networks, genetic highways that kept isolated populations connected. Enjoyed the sleep story? Subscribe for more relaxing history and bedtime tales. Share your thoughts in the comments. And tell me what you'd like to listen to in the next video. We're working on the next part, and we'll upload it shortly. Good night, sweet dreams.